So welcome to our lesson on terminal management and power supply in computer system. So today we're actually still in week 2 and where we are talking about building and configuring computer systems. So today we'll explore how these crucial components work together to ensure stability, efficiency, and longevity of our computers. Understanding this concept is crucial for anyone working with computer hardware and building their own systems. So by the end of this lesson, you have a solid grasp of why terminal management is crucial, the different cooling methods available, and how to choose the right one for your system. So we'll also dive into power supply unit, understanding these specifications and how they contribute to overall system stability and efficiency. Computer generate heat as a byproduct of electrical current flowing through their components. The main heat generating parts are the CPU, the GPU, and the power supply unit. Excessive heat can lead to terminal throttling and reduced performance, system instability, and even permanent hardware damage. So this is why it's very effective to actually manage terminal heat, and is crucial for any component. So there are several approaches to managing heat in a computer system. So we have the air cooling, which uses fans or heat sink to dispatch heat, and it is the most common method. Then we have the liquid cooling, circulates coolant through the systems for effective heat transfer. Then we have passive cooling, relies on the heat sink and the natural convection without fans. Terminal interference materials improve heat transfer between the components and the cooling solutions. Air cooling is the most widely used method due to its simplicity and cost effectiveness. It involves case fans for overall airflow, CPU coolers with heatsink and fans, and they have dedicated fans for also graphics card. Proper airflow is crucial, which is actually typically they have front and the bottom fans actually are the ones that take in the air. So the fan in the front and the one under takes in air, while the ones on top and the ones at the back actually the one that remove the hot air, they exhaust the hot air. Air cooling is easy to maintain, but when you're actually working with high performance or overclocked systems, it's actually not easy, and it may struggle during those types of configuration. So over on this our image here, you see a system unit with a heat sink and the fans that are on it, actually removing the hot air. The other one that comes from the front, which is the inlet that has collects fresh air. I mean air that are actually entering the system. It absorbs it and passes it to the CPU. The other one actually takes out the air over here and actually sends it out to this rear one that actually sends hot air out, while this one in the front is actually the one that absorbs air in. This front fans and these bottom fans are actually the ones that are dedicated for bringing in air to the system, and actually this fan is the one that takes air out. With these two, they actually take hot air out. So why am I saying this? In case you're actually working on a system, it's not that it's actually like this, but this is the convention. You can actually build your own system and configure it based on the position you want to be keeping your system unit, and you may now know how to actually reconfigure these components. Then we have the cooling, liquid cooling, which offers superior heat dispersion compared to air cooling. AIO coolants are pre-built. So we have AIO coolers which are pre-built sealed units that are relatively easy to install. Then we have custom loop systems, often for best cooling performance, but require more expertise to set up and maintain. So liquid cooling is quiet, and more efficient than air cooling, but comes with higher costs and potential risks of leaks. So actually here is actually where you have your CPU cooler. You see actually water flowing through both the GPU and the computer system, the NOT bridge and your CPU here. So it has the one for inlet that takes in cool air. You have the one that takes out the hot air, the cool water. You have the one that takes out the hot water. So these components are actually how they transfer heat into the system to cool each and every of the components that actually dissipate or generate heat. Modern computers have multiple temperature sensors to monitor crucial components. The BIOS or the UFI interface allows user to set fan curves and control how fans respond to temperature changes. Software tools like MSI Afterburner, we have HAW monitor or speed fans provide real-time temperature monitoring and fan control, helping users optimize their system terminal performance. So actually, the PCU actually have some temperature measurement softwares you can actually install. Some comes pre-built, like MSI has its own software that is built on mostly on the BIOS, where you can actually control the way your CPU fan cools, the speed, and actually calculates also the heat for you. Then you have others you can install like the speed fan and the HW monitor. So these are actually tools you can use to manage dispersion of heat and temperature your system is running in. Then we have the power supply unit. This is the heart of any computer system. It provides stable and clean power to all components, but the key specification to consider are the wattage, which is the total power output, the total power the PCU is producing. Then efficient rating, which is 80 plus certification levels, and modulity, which is fixed or modular cables. They are fixed cables that those cables they just match exactly with your motherboard power sockets on the board. Or you have the one that are modular. That means you just have to try fixing it. Any one that remains, you just leave it flying. So then a reliable CPU is actually crucial for system stability and longevity. Choosing the right wattage PCU is crucial. Start by calculating your system power requirement based on the components like your CPU, your GPU, your storage drives, and peripherals. Also add some headroom, typically maybe 20% or 30% extra, to account for power spikes or future upgrade. Online PCU calculators can help estimate your need, but it's always better to err on the side of caution. So over here, you look at our diagram, you see the PCU, the sticker over here is actually here where you can see the 80 plus sticker rating. So here is actually where you can look at power rating on the PCU. So PCU efficiency refers to how much of the drain power is converted to usable power for your components. The 80 plus certification rates CPU from standard, which is 80 efficiency, up to titanium, which is 94% efficiency at certain loads. So higher efficiency means less energy is wasted as heat, resulting in cooler operation and lower electric bills, and often quieter performance due to less need for cooling. So over here, you look at your rating, you see 80 plus, browse, and down to titanium. So you see their efficiency rate in their loading, and you see how it increases over time. Then you see efficiency rate based on 50% and 100%. So this is actually the rating you need to watch out for or look out for when you're building your PC. Then modular versus unmodular PC. So modular PC allows you to connect only cables you need, while non-modular PCUs have all cables permanently attached. The semi-modular cables are middle ground, with essential cables fixed and others are optional. So the modular PCU offer better cable management and airflow, but are more expensive. Then you have the non-modular PCU are cheaper but can lead to cluster build. Consider your case size and goals and build goals when choosing. So you have over here, you have your modular PCU, which doesn't have cable flying out. You plug only the cables you need to read. Then you have your semi-modular, which is actually in the middle. You have some cables that are essential, that are out for you. Then you have others which you can plug in it. Then you have the non-modular, which allows you to plug all cables, all the cables that you need. Every cable is flying out. So you choose one you need and leave the one that you don't need. It will be flying out. So you don't have the option of attaching the ones you need and not plugging the ones you don't need. Then quality PCUs include several safety features to protect your system. You have OVP and the UVP, prevent damage from voltage fluctuations. Then you have the SEP, which protects against short circuit, while you have OPP, prevents the CPU from delivering more power than it's rated for. These features are crucial for protecting your expensive components and ensuring system longevity. Then you have PCU efficiency directly affects how much the heat it generates. A more efficient PCU provides less heat, contributing to better overall system terminals. The PCU placement in the case, typically bottom mounted in most cases, can influence the way air flow in your system. Many high quality PCUs have temperature controlled fans that only spin up when they have much load. If there's no much load, they don't spin. So contributing to quiet or quieter operation. Best practices to maintain optimal terminal performance and power delivery. Regularly clean your system to prevent dust buildup. Manage cabling neatly to improve airflow. Use software tools to monitor temperatures and power usage, and invest in quality terminal solutions and power supplies. These practices will ensure your system runs cool, quiet, and efficiently. We have covered all the essentials of thermal management and power supply in computer systems. Remember, a well-cooled system with a reliable power supply is key to stability, performance, and longevity. Always consider your specific needs and use case when choosing cooling solutions and power supplies. Is there any question you have based on what we have discussed today? Feel free to drop it in the comment section below or in our classroom stream where we'll attend to it promptly. See you in our next class.